Welcome to building the STELLA 1.2 Base Module. Thank you for your interest, and here are some of the tools you'll need. Wire strippers, snips, breadboard, solder iron, multimeter, hobby knife, marker, tape, flux, needle nose pliers, and a soldering braid. Here are the 3D parts you will need to print in order to make the base module. STELLA 1.2 base, face, the work mount, coupler guide, clock spacer, sensor clip, and a micro SD latch. Now, in order to set things up, here are all the various 3D printed parts and where they go onto the base. There you have the coupler alignment pieces, you have the clock spacer, okay, the base mount and the faceplate, as well as the sensor clip, okay? And finally, you're going to have the SD holster, which is that nice little green piece. Here are the parts needed to build your base. Please refer to the parts list in the description. You'll need a full-size proto board, Feather ESP32-S3, Rotary encoder, power button, I-SPI breakout, display, and SD card module. You also need a micro SD card, ultimate GPS breakout, capacitor, RTC clock module, 2 coin batteries, QT breakout, and 5-volt boost, quick connect cable, battery, USB-C data cable, ambient air sensor. Now it's time to build the module. I start by marking the proto board at the A1 mark on the back so I can easily identify where A1 or the A1 side is located. That's quite useful. I'm also using my 3D printed base to do all of my work on. It's a very handy tool that Paul Mirel designed. And you can see I'm flipping over the board to show you where A1 is. And then I'm going to sever the connections. So you're cutting these traces here, okay, according to the wiring guide, and you can see which ones to cut up on the display. And you want to make sure you cut out a good segment of them. And then later on, I will test those cuts to make sure that there is no continuity between them using my digital multimeter. Look for a diode symbol with propagation waves around it on your digital multimeter. That should make a nice beeping sound when there's continuity. We are severing the continuity, so that it should not beep between these points that we severed, these traces. So when it beeps, there's continuity, and that's not what we want. We want that to make sure that those traces are severed. And here are the finished cuts for the proto board. So if you follow the instructions correctly, those cuts should not have any continuity between them. I will check them later as I wire it up to make sure that there's no continuity. Now, you use your delightful alignment tool here. This is going to be for the flat pins. You do not want the ones with the pins sticking out. So these are the flats of the 3-pin and 4-pin. And then I like to tape them down to the proto board, okay? And that way they stay in position, because there might be some wires being fed through there. I know we do that with some of the other components, and I make sure that you know, that I can still see the basically the leads coming in through the pinholes. Okay, once I have it set up, I'll wire it up. And for this particular version, you know, we're making some connects, so we go from the like A2 area to the A1 area and all that. And as I put those wires in there, I leave a little extra length on there, and then I test the continuity to make sure there's no bridging. If there's any bridging that we don't want, you have to take a look and make sure that none of the solder is touching. In this case, everything is looking pretty good, and we're going to go ahead and continue the wiring operation of these couplers. All right, checking everything, make sure it's looking good. All right, and now we're going to check our wiring guide and take a look at what's next. We're going to pull out our nice green wire and get it stripped and stick it down in and measure the length. Okay, and feed it to the point that it needs to go to. All right, and I like to check and make sure and leave a little bit of length and a little bit of slack, just a touch, because you're going to need to move these wires out of the way a little bit. And then, like I said, bend it forward, put a little flux on there, okay, and on all the points that I'm going to solder from here, okay, and put a little bit of solder on there. You don't need a ton, but we do want it to bridge from one point to the other. I believe this one is from C1 to C2. So I did put an extra length of wire on there so I can make that bridge. And you can test the continuity if you need to with the multimeter and the beep test. Okay. And I definitely want to check my points, make sure I'm oriented correctly. All right. The wires are looking pretty good. And we'll start wiring up the rest of the coupler here. Okay, and that one is going from D2 to D1 and to the SDA above 2J or J2. Okay, and like I said, check everything out. You know, this one is it's a very fun build. This Paul really outdid himself with this Stella base module. Any other modules to come? Again, he's the creator and lead engineer of the Stella. So I put a little bit of flux there, and now I'm soldering the wire in. Now that I have the first coupler basically in, after I clean it up a bit, I'm going to test for continuity. It's a good thing to, again, test for continuity just to be sure, because, you don't want any unnecessary bridging, and, after having done a few of these different Stellas, you never know when there's just might be the tiniest touch of solder. So this is what a finished coupler looks like for the, and that's just the 4-pin coupler. The 3-pin coupler we will come out with, or we'll show you a little bit later in the video. Okay. Okay, so now that we have that in, we need to install our Qwiic breakout. These are amazing little breakouts with the Qwiic connector cables. Now this one is very special. Is a nice specialty because we have to take out the 2 middle pins in here. So I like to line it up first and actually use a little piece of header. Then you'll see that right under there to hold it up, and make it nice and even. And I'm just going to do the 2 outside pins here. I'm going to solder the 2 outside pins here, make sure it's aligned, make sure I like it, gently wiggle it out, okay? And then I'm going to break out, and it's just a little off screen at the moment, but I'm going to break out the 2 central pins there, okay, for this one, and I'm going to keep the 2 outside pins, all right? And then I'm going to install that on the rear of the board, okay, up at the front, and you'll see like the nice hole in the middle there, okay. And so again, Paul, being the genius he is with this nice board here, this nice 3D mount, it's got a nice little plug-in to help support and keep your pins aligned. So, and so it lines it all up really nicely, and I put some tape over it to make sure it stays that way, and then I'll solder those pins on in and put the wires in. Okay, so there's my piece of tape. All right, now I can solder it through there or any other place I feel like doing. And again, this is a fun little soldering job in here. I've had a lot of fun, experimenting with different ways of doing this type of thing. Okay. And it's okay to keep a bit of pin out of there because we're going to be putting wires back in there around those pins probably in just a bit. And you'll see that when it comes up in just a bit. So I make sure everything's looking good before I continue my operation. And then you clean up my workspace a little bit. It's a little untidy and unkempt at the moment. Okay, so let's continue this awesome build. Again, one of the great things about the Stella 1.2 module design is that the display breakout is much simpler to put together, and all the wiring is pretty much on the one side, so that's pretty sweet as well. So right now I'm bending a little hook in there on the two outside pins to clip in. Now there's a few different approaches you can try and go about this. I kind of like this approach of clipping it in there. I think the next approach I might try to take is taping it down, putting the wire in there, and then soldering the two together. I think that might be maybe an easier way to go, but again, it is kind of fun and unique trying to get those wires around and soldering them in. So this has a lot of fun aspects to it, where you don't treat the proto board as a sacred thing, and so you're sort of tearing into it and using it, using its design to your benefit. So again, very fun build. There you go. I soldered that in. Make sure it's got a good connection. Okay, and make sure everything's cleaned up. We don't want any bridging, any unnecessary bridging. And make sure that it has enough coating on there, of course, to make sure that there is no potential for any kind of unwanted bridging as well. All right, so there's my there's my voltage wire. Okay. It looks like I'm just cleaning things up, making sure that they all fit well. And I know it's a little bit harder to see, somewhat. Yeah, I'm just checking things out. All right, measuring where it's going to go. Stripping, popping it into the pin. Okay. And now, if I'm not mistaken, this isn't a completely perfect build, so it's not a, I did make a mistake or two. I don't believe this is one of them, but they're a little later on, and then going back and discovering, that mistake, because it doesn't matter how many times you look at like the wiring sheet or the build, or how many times you've built these types of things. Sometimes you just mess up and you put a pin in the wrong, or a wire in the wrong pinhole, and or a little piece of wire ends up on there, and there's a little bit of bridging. And part of the fun is actually tracking down the problem, at least for me. And again, since this is relatively, it's a simpler build certainly than the 1.1. It is kind of fun to track it down. It really helps you appreciate, how much time and intensity it takes to actually, formulate these projects, these builds. Because again, it's like coding. Little mistake here or there, you put an apostrophe in the wrong place, you put a wire in the wrong place, just by accident, and it messes up the whole thing. You got to track it down. So still a lot of fun. So let's see. So we're getting that all connected up. All right. And that's looking pretty good. Once we get that microcontroller installed after this, we'll have fun testing out our Qwiic breakout. So these two wires go in the big hole, and this is kind of one of my favorite little aspects of this build. Again, it's just such a fun, creative way of putting this all together. Again, that's what you get when you get a project from a master engineer. So, making sure again that there's a bit of slack in there. You don't need a huge amount, but you do need to be able to maneuver the wires a bit, because you do have to get into some of the other areas of the board up here. All the wiring is done on the front of the Proto board here in this particular version. It makes it much simpler. Right, a little bit of flux, and we go ahead and solder. Okay. Now, I like to think my soldering skills have gotten better over the last few years, but they're definitely not, I don't have the mastery yet. I've seen folks solder that just, it blows my mind how well they're able to do it and how fast. And it looks so easy. But like anything, the more you do it, the better you get, and man, there are people with skills. So now we're testing the microcontroller. So plugging that in. So in order to test it, you got to hold down the boot button, drag and drop the latest UF2 file into the feather boot. So basically, when you plug it in, you hold the boot down, the feather boot drive comes up, and you drag and drop the UF2. Then it goes ahead and disconnects and comes into Circuit Pi. With the Circuit Pi, that's where you take in your test codes and your libraries and all that. So we have a bunch of test codes. So in this case, there's already libraries in there. So you want to go to the test code area, or the actual code, and get the libraries and the TOML and all those files, and drag and drop them in there. Everything except for the archive file in that one. But then you do the code.py in here for your tests, and you test out this microcontroller. So right now we're rebooting, and we get to see, hey, our microcontroller is working pretty well. Okay. Now we're going to put the header pins on the microcontroller, and I don't know what it is, but there's always just something that I love. It's so relaxing to go ahead and just solder a bunch of header pins in. I don't know. Yeah, I align it on the breadboard nice and neat. And I'm sorry that I keep slipping the stuff out of focus a little bit. But I adjust the breadboard so that it's right under, so you can see. Okay, and I don't try to make a lengthy stay of it on the breadboard, on the pins with the soldering iron. Try to sort of get in and get out, make nice little volcanoes or TPs. Yeah, definitely trying to keep it from bridging. Make sure you clean your solder iron often. It's starting to get a little gunked up here. I probably should have cleaned it a little bit ago. But yeah, definitely in between each sort of component and all that, make sure your soldering iron is clean. Touching up a bit of solder, making sure there's no cold connections or anything like that. No cold solder. Okay. Alrighty. So now I'm going ahead and identifying where the pins go based upon the wiring sheet. Okay, and aligning them all up. Then I tape the microprocessor down once I'm happy. And I usually get, for this one, it's a sort of a bigger chip, so I'll get like the outside 4 pins to start. Okay, I will do flux kind of all over it, but get the outside 4 pins. That way, if I need to, and I'll take it up and look and make sure that everything is aligned, make sure there's no gaps. And that way, if there is, I can push in the microcontroller and, get it nice and flush with the Proto board. And then I can go ahead and do the rest of the pins. Okay, you want it nice and flush. You want everything, mounted correctly, because it's much better structure. Plus, there are some tighter tolerances in the Stella build and all that. So you want everything properly aligned. All right, and yeah, once I finish soldering this all up, I'm going to trim those pins. No, hold over the wastebasket to do it. Okay, so I'm taking it to the wastebasket and holding over while I trim the pins up. You don't need to trim them down to the complete nub, but you want to trim them down a bit. All right, now I'm going to wire up the microcontroller. All right, so you want your ground line to your ground line, and your 3 volt to your 3 volt, serial clock to serial clock, and serial data to serial data. So serial clock will be your negative, basically connections above J, and the serial data will be the positive connections above J. Okay, the positive trace. All right. And these are some shorter wires, because there's not too huge of a gap to go over. Flux it on up. Solder your wires on in. Now, once we have our board cleaned up, we're going to test our Qwiic Connect. When you test your Qwiic Connect, make sure that the shiny side of the Qwiic Connect cable is facing towards the breakout board. And so that's kind of what I'm pointing at when I show that. When you plug it all in, you should see the light come on your clock breakout. So we attach our clock breakout to the circuit, to the Qwiic Connect. Then we bring in our code.py into the CircuitPy, let it load, and when it loads, okay, we're going to take a look in our serial area of our mu editor, okay, and we're going to look at the UTC time, okay, and so we're going to enter this time in UTC, all right. All right, and once you have everything entered in and you hit enter, you check and make sure the time is okay in the clock module. Now we're going to install and test the rotary encoder. So first we're going to snip off the tabs of our rotary encoder once we've unpackaged it. Okay, make sure they're nice and clean, so you snip those off. Okay, so you want the rotary encoder to sit flush on your proto board. Should sit on H37, H39, D37, D38, and D39 on the rear. So make sure it's on the rear of your proto board. Once you have that set in place, I tape it up. I like to tape it, and again, I just do maybe 4 of the soldering points. Make sure that it's sitting flush. In this case, I might do all of them, but that way you can adjust it and make sure that it's aligned if need be. Okay. And once you have that, then you perform the wiring. So wiring for him here is going to be A31 to the ground below A, F35 to the ground below A, I35 to I37, again another ground wire. The push button switch, which is J39 to J46. The rotary line B, which is A39 to A50. And rotary line A, which is A37 to A51. All in the appropriate colors. Again, I might leave a little bit of slack for some of the ones that aren't straight down. Just again to be able to maneuver the wires if I need to. The ones going across lengthwise, I definitely leave a little bit of slack if I need to maneuver out of the way. I like trying to make nice little arcs there. You can move them all together. Make sure you bend the backs, of course, of the wires so that they don't move as you're soldering them in. And of course, try not to melt any of the other pieces around. So maneuvering your soldering iron is always a nice, cautious job. Clean up your board by trimming some of the excess wire off. Okay, and then we plug it in and we test. Okay, so we're going to test the rotary encoder here. And again, you go down to your test codes. This would be C here, and you drag and drop into CircuitPy. Okay, again, making sure that you've already had your libraries and stuff in there, and then you start testing the rotary control. So I'm twisting it back and forth, and I'm pushing it and making sure that it's being able to read everything. Next, install the iSpy and test the display. You must solder those jumpers, IM1, IM2, and IM3 on the display board. Okay. Once I have that, soldered up, those connections made on those jumpers, I sort of set the display off to the side. All right. I put it in this nice handy box, and then I get the iSpy. Now I'm going to put the iSpy on my breadboard, make sure it's lined all up, make sure everything's looking good. Again, I might again, when you install the iSpy onto the Proto board, you want to make sure you have it facing towards J, the black bar facing towards J. Now on this breadboard, I don't really care that much. I'm basically just aligning the pins. So I'm going to do the outside 4 first, take a look, make sure that it's sitting flush against the pin, against the headers, and then I'm going to go ahead and finish up all the rest of the pins here. Okay. Again, one of my favorite, more relaxing things to do. Once you have that installed, then on the front of there, you're doing D24 to 32 and G24 to 32. And make sure the latch bar, the black latch bar, is towards J. Okay, again, first 4 pins, make sure that it's level, make sure it's flush. Okay, I might push on it just a bit while I melt the solder there so that it is flush and it is looking good against the proto board. Then I'll go ahead and solder the rest of the pins in. Put a little flux on there first, of course, and make sure those are soldered in. And again, when the solder starts coming out a little gloppy or whatever, it's over past time to go ahead and clean up your soldering iron. Okay, now with that completed, here's what the SB breakout looks like without the wired connections. So that's what we get to do next, is wire this all up. And remember to leave a bit of slack in your wires, because you will have to move them around a bit. But make sure that they're pretty flush with the proto board so that there's no exposed wire, so you don't have any unnecessary bridging. And we'll get started on this install. Alright, so we're putting the ground, and this is the 3 volts, the power. Okay. And the ground. Power goes from A24 to positive, the ground from A26 to the ground, negative. Okay. Got your yellow wire, which is your SCK, and that's going to go from A27 to A49. Then you'll have your MOSI, and we do that in a green wire from A28 to A48. Blue wire, which is your MISO, which is A29 to A47. Okay. After that, you have your touchscreen DC, that's going to be A30 to J48. Okay, your touchscreen reset, which is A31 to J49. Okay, and your touchscreen CS, which is A32 to J50. Okay, SCL is J27 to the negative above J, and your SDA is to the positive above J. Okay, from J28 to a positive. Then your touchscreen interrupt is going to be J29 to J51. Okay, and I'm pointing out here, basically to leave a bit of slack in these lines as you wire this on up. And I like to make these nice little arcs here. Make it a little bit loose. It does make, you do have to sort of tuck that in. Eventually, once you put it into the base frame of the 1.2, but again, you're going to need a little bit of slack. So, see, measuring out how much wire I'll need. Again, so this basically eliminates the need to make what we called the sandwich layer of the display screen in the Stella 1.1. So using this iSpy breakout is fantastic. And later on, once we have this all wired up, we can test the continuity. So once we get this all wired up and we put the iSpy cable in here, you'll see that we can test on the display basically continuity between it and the wires from the pins from the breakout board. MISO to MISO, MOSI to MOSI, and so on and so forth. And make sure that the connection is going through. Get that nice and fluxed up. Get that all nice and soldered. Try not to get any bridging over there. And clean up our proto board. Some wires are trickier than others. There it goes, looking pretty clean, pretty nice. Let's see, let's grab our display. And now we install our iSpy cable. Okay, make sure it gets in there nice and snug, and then close the latch down. You want the blue side up and the basically the exposed wire down. Okay, and again, same thing with the display board. Close the latch, make sure it's in there nice and snug. Should fit in pretty well. Okay, you might need to wiggle it just a little bit to get it in there nice and flush. Alright, once we have that all in there, then we get to then we will test. We'll test our continuity first, and right now I'm just testing the continuity between various different points on here to make sure that everything is flowing through just fine. Okay. Just using the beep functionality of the digital multimeter. And once that looks good, plug it in and drag and drop our display code into CircuitPy. There we go. Our display should come up and look like this if the display code is working correctly. See that nice red outline, blue square. Now we're going to test our touchscreen. We drag our code.py from the touchscreen test codes, and when it eventually finishes copying over, there we go, let's try it again. Our touchscreen should boot up, and you'll see no touch, and then you start touching your screen and those will come up. And once you see that it's detecting your touches, that means that your display touchscreen is working correctly. You can unplug, and I put the screen away back in its little box until I'm ready to install it for good. Now, okay, let's start installing, getting ready to install the 5-volt boost. Okay, so right now we're doing the 5-volt boost. That one's mostly going to be for the methane sensor at the most point that we're adding onto the STELLA-1.2. Okay, and just to note, we do have it working. And again, with the headers, I do the outside 2 pins first, just to make sure that everything's looking aligned, is it straight up and down, because sometimes it gets slanted and all that sort of stuff. But I definitely tape it down, make good use of the tape. Okay, and you can trim that up and cut that off, and I'm taking it to the waste basket to do so, to cut those pins. Okay, once you're ready and back, then we get to have some more fun popping in some more wires. We got a few resistors that we're going to pop in there. So, and these are a lot of fun to put in. This is everything. I'm just a big fan of building these. And so we're going to use some 10K ohm resistors. Okay, you'll need 3 of them, and you're gonna pop them in. Okay, they're going to go from H20 to H23, H16 to H19, and G13 to G16. Okay, the boost pins, the ones with the headers and all that, that was G17 to G20. Okay. Now, one of the things that you are going to do eventually is cut the trace for the clock for the front of on the front of the module. There's only one real jumper area for the clock, so, and we'll get to that in just a moment. Yeah, install the resistors. I don't know what it is about resistors. They're a lot of fun. Flux them on up. Okay, it's feeling pretty good, looking pretty good. Trim those on down. And you want to make sure and do it in this order. I'm cleaning up the board a little bit, just because the resistors are going to be underneath of the 5-volt breakout at a certain point. So let's see there. Here's the clock module, and again, there's, I'm trying to point it out to with my big old meaty fingers, the little jumper trace. So I'm going to sever the jumper trace, with my, well, I got a utility knife, but you can use your hobby knife. Check the continuity. Okay, if it doesn't beep, that's good. We want to make sure it doesn't beep. Okay, then it's severed, so the LED's on. There's your clock spacer, 3D printed clock spacer, and I got that on kind of backwards. There you go. You want to put the header pins over the gap in the back, and then when you put those header pins in, you're going to trim them up. Make sure they fit into that spacer. Okay, so I shaved down the sides. I've definitely noticed that you have to shave down the sides just a little bit to make sure it fits in that spacer. Okay. And once you do, again, fit it on. I set it right on there. It sits very nicely, very flush with everything. So I go ahead and solder it while it's on that perma board, and then I'll tape it down and solder it. And this is one of my favorite pieces of 3D printed, at least the spacer and all that. Again, the attention to detail Paul put into this to create, this 3D spacer, so that it's got these nice little gaps for the wires to come through. And let's see. Yep, I do the outsides first. Then I'm going to take tape off, make sure that it's looking good, make sure there's no gaps or air gaps or anything like that. Okay, see if I need to adjust, and if I don't, then I go ahead and solder the rest of the pins. All right. So that's the clock. So we're still working on sort of the 5-volt boost, but this clock module has to go in there first. Okay. Now you get to wire it all up. And so you're going to go around the spacer with this particular wire. But again, the ones that go through it are just, it's just a lot of fun, I see all these like little touches, these little unbelievable attentions to, or just attention to detail. And then, you start to understand why Paul is a world-class engineer. Maybe I'm giving him too much of an ego. But no, he deserves it. Okay. Here I'm attaching a bunch of ground wires, and after I do some of these ground wires and all that, I might take a look and see how the continuity is going on with them. So you install the clock at B16 to B20, ground wires from F13 to the ground, the negative ground below A, J13 to J18, and J23 to J35. Okay. And like I said, once you have that all installed, if you feel like it, test the continuity. It's never really a bad idea to check to make sure that everything's hooked up correctly. And in fact, I believe in this build, I did make a small mistake where where there was some bridging or a misplaced wire. So it's always good to go back over your wiring list and check to see how you're doing. And I wish I had done like these things perfectly, but you just, we're only human. So. Okay, and here's the 5-volt enable wire. Okay, so see, we're getting to the 5 volts, to the 5-volt boost. A lot of these wires, again, they get sort of obfuscated by the 5-volt breakout. So we want to put them on in this order, so that everything that is tucked underneath of the 5-volt breakout is there, and we don't have to go back, and try and either fish it under there or have to take the breakout off and then put it back on there, because that's always obnoxious. Alright, and if everything's looking good, there we go. Finish connecting the wires. So the 5-volt boost enables goes from I20 to I33, from G33 to J47. Okay. Then you have the VBAT unregulated lithium battery output on the front, and the brown wire goes from J12 to J55, and from I12 to I17. Now, if I haven't done every single wire on here, I apologize, but again, there is the wire list to refer to, and I would definitely go with that. And again, this is also at a sped up frame rate or sped up time. Otherwise, this might be sort of a multi-hour build, and I don't know if you'd have the patience to sit here and watch me while I fiddled around, trying to find my snips, or where did I put that breakout? Every now and again, they get sort of lost in the shuffle of all the little breakout pieces and stuff that I have around here. So this is the 5-volt monitor at 2.5 volts, and this is yellow wire from J16 to J34 and F34 to A53. Okay. Make sure to get all these nice yellow wires over here. And see, once the wires start getting closer and closer together, sometimes there's, like I said, there's a little mix-up. You put it through one wrong hole, and you're like, and you have to go back and desolder and then rewire. And it happens. And you notice that I left still. I'm going to leave slack in pretty much all the wires here, unless they're usually like sort of the direct connects, which are it's like from like A30 to the A30 plus bus. Okay, and this one is the 5-volt power, and this goes from J1 to J2. So this is again one of the magnetic couplers, the 3-pin magnetic coupler from J1 to J2 and to J19. Okay. And once we have that installed and the continuity is good and it's not bridging and all that, because I did check. Once all these are nice and soldered in, then we'll install the boost module. It's always fun to get multiple wires done, but again, when you start doing multiple wires, that's when the real screw-ups happen, because you're like, oh, I've done so many wires. And then you're feeling so confident, so good, you're like, yes, I think they're all in the right place. It's always worth going back and checking, but yeah. Sometimes you get a little too cocky, like, oh, I've done this so many times, or I think I got a good handle on it, and again, that's when the accidents happen. So there's the 5-volt boost, nice little chip. You pop that over, and you can see it's over multiple wires and resistors and all that. Okay, and it's right near the clock, so be careful. Really, you gotta sort of angle your solder iron up and get in there. So pretty tight fixed. You don't want to hit anything else with the solder iron if you can help it. Get in and get out. Make sure that make sure that they're good solder joints. So. All right, now here's part of the fun. Okay, we're going to hook up the clock as well. Okay, so we're going to hit up the ground and go through. All right. Now you could have done the 5-volt test beforehand, but I kind of liked to pair these two up because it's a few wires. Okay, so from A19 to the ground below A. Okay, and then 3-volt, which is A20 to the positive below A. And then here's where the fun ones come in. These are my favorite. The serial clock that runs under the spacer, the green wire, which is A18 to the CL or serial clock negative above J. And then the white wire, which is run under the spacer as well from the other spacer portion of the spacer from A17 to the positive above J, the serial data line. Lots of fun. These are where also the tiny pliers sort of come in handy as well, because sometimes it's hard to fish it through there and pick it up above the stuff that's in the way. So I use the tiny pliers to get those up there. But again, really, really fun little build. Tiny pliers. Length snip. And it's a little too long. There you go. Just right. Nope. Not just right. There you go. I don't mind a little slack, but I don't want a ton. Alright. Then we solder. And clean up your board. Station gets messier and messier as you go along. Alright. Now let's plug it in. Use your USB-C data cable. Okay, and boot it up and take a look at your Mu editor, alright, under the serial. Okay, and to do so, basically, again, this is drag and drop code. Drag and drop it into the Circuit Pi for a 5-volt boost and test, okay? And it should load up, and once it does, you'll get to see that the 5-volt line is working. So it'll loop through and check, whether when it's on and off as to how much voltage is going through. All right, fantastic. Okay, and again, you can check out the clock test code again. Make sure that once it's soldered in, that you're seeing that the data is correct and all that. And if you need a repeat of that, go back to where we first set the clock up so that you can see that it's installed. So it should come up in UTC. All right, now we're installing the red power wire, okay, for our SD card module, and we're doing it from D3 to the positive below A. And afterwards, we'll do our ground wire from D4 to the negative wire below A. Okay. For our SD card, we're also going to install the pins first from B3 to B11 on the rear. Okay, so let's get these wires installed here. All right. Let's see what size headers we need. I'm shaping up the ground wire here as well. So pop this ground wire in. And now we get our SD card breakout. Now we want to install our header pins first, and here's where we got to move some wires. Okay, so we move those wires a bit, and we can hopefully get our header pins in there pretty well. Let's take a look. May need to do a little taping. There we go. Flux it on up. Solder. Try not to touch any of the other wires. You don't want to burn any of the sheathing off. Now I'm doing the outside two again. Start. Take the tape off and take a look. See how the headers are looking. Is it flush? Is it angled? Do I need to adjust? That looks pretty good. I'll get these wires on in. Get the rest of these pins soldered. Make sure they're good to go. Let's see. Alright, you see that little 3D spacer in there? That will help hold up your module. Okay, so helps hold your module nice and level. Press down a little bit. Little flux. And go ahead and solder that pin on it, that chip on it. Make sure you're making contact with the pin and the ring so the solder can follow the heat. Make sure everything is looking good. And then we get to put the wiring in. So for the SDK for the front, you're going to go from D5 to B27 in a yellow cable. For MISO for the front, you're going to go from D6 to B29 with a blue cable. MOSI, D7 to B28 with a green cable. Okay. And SD card reader CS, you're going to go from D8 to A52 with a gray cable. Once we get this all wired up and looking good, then we will test it. Now, if you notice, I definitely made a mistake here. So I'm starting to wire up actually because I was looking at it, the GPS area. And I eventually noticed my mistake. I think I only get one wire in before I'm like, oh, yeah, I've skipped a board, a chip. Okay, so if we're skipping ahead, this is the brown wire, the VBET wire for the GPS module. Again, I accidentally skipped ahead for this particular portion. I should be wiring up the SD card, but you know, I guess in the wiring list, I wasn't really paying terribly close attention. So I started wiring up the the GPS module. I eventually catch my mistake. But you know, so we got the VBET, and now we need to test the grounding wire. And again, all these wires eventually go in there, but again, it's a mistake to start on these before getting the SD card hooked in and tested. And I believe that's what this hesitation is. Me looking again at the wiring chart and figuring, oh yeah, there's no reason this would go here yet. All right, so now we're back on track. Okay, and we're putting SD card reader SCK from D5 to B27. All right. And then, as stated before, MISO is going to be from, which is a blue wire, from D6 to B29. MOSI from D7 to B28 is going to be a green wire, and then your SDCS is going to be from D8 to A52. And actually, kind of like those longer header pins to help sort out the wires. Little needle nose pliers. All right. Let's see. What's next? Strip off the tips. A little slack. Pulling out the wires, making sure that they're taut and looking good. There we go. Nice long gray wire. All right, get on in there. There we go. I need a longer gray wire. It just wasn't slightly long enough. I like to reuse my wires, so if I can. I hate wasting a wire, even if it's a somewhat short length. Maybe that was long enough either. Darn it. There we go. I think we might have a winner here. Yeah, each time I pull it towards me, it's, basically because I'm putting a little pressure on there, making sure that the wires are bent the right way. Yeah. It's harder to see, like, with the phone hovering over everything. Alright, let's solder these guys on in. Solder in the ones I put in that were a little bit ahead of their time. They'll have their time now. Not a huge mistake. Not the worst one I've made for sure. Alright, let's clean up the board. Always fun time. Clean up the board and mess up the workspace. Make sure that yeah, we don't want any cold solders. So. Alright, and that's looking pretty good. So, we're getting to the point where we need to test. So let's plug in our USB data cable. Let's hook up to the Mu editor on our computer. Okay, and let's test this out. Alright, so you're going to make sure you have an SD card put in there. You drag and drop your code PY into the circuit PY. Alright, and then once it's loaded up, eventually you will get some code. There we go. That basically says it's printing lines and files on your SD card, and everything should be cool in the game. Alright, once you're done with that, it's time to install the GPS and test it out. Alright, so let us grab some wires, our board, and our chip, and get ready to install GPS. Now, as I said before, I've already started a little bit on this with the brown VBAT wire from G4 to G12 and the ground wire from E4 to E5. Right around the time I was starting the GPS enable wire, the 3-volt wire, power wire from F10 to the positive below A13, I realized that I was doing stuff in advance. Okay, so I'm going to take out my, it looks like I'm going to take out my multimeter here, and I'm going to test some continuity here. Okay, because I might have some bridging going on. So let's take a look and see what's going down here. All right, there's something that I don't like. So I'm going to test out the continuity, make sure that these are going from end to end, from point to point. Okay. Test these things out, make sure that they're good. Oh. I was going to the wrong spot. Wrong spot. Let me clean this on up here. There we go. We'll sever that wire. We're going to take those out, and we're going to pop in some new wire. Okay, so this was a bit of a mistake here with the SD card MISO reader. Looks like so. A little solder on there, and I should be able to get it on through. There you go. Make sure that we have enough space. There we go. Able to put it in. Went on through. That's nice, and we'll clean it up. Boom. All right. Boom goes the dynamite. All right, let's go ahead and measure here, and we'll do about the same thing over here. And clean this area up. Feed this on through. Okay, into the right proper hole. Okay, solder it on up. So again, nice little mistake. They happen. Rectify the error, hopefully, and move on. Next, we'll plug it in, make sure it's all tested. Okay, and it looks good over here. There's an SD card. All right, now things look good. Checking the couplers. Always checking to see if there's any more bridging or anything. Alright, now we're going to grab our GPS breakout. There we go. Nice GPS. Make sure that the headers are trimmed down to the appropriate size for the amount of pins need to go in there. Okay. When we do our GPS, we do the install pins first. Okay, from H11 to H3, or H3 to H11. First, we're putting in our 0.1 UF capacitor. Okay, not polarized, and we're putting that in from I4 to I5. A little something in the way there. Not letting it go in easily enough, so the wires, I had to adjust them just a bit. Alright, see, and to pop the headers on there, tape them on up. Okay. Make sure everything's snug. Okay, try not to melt any wires or anything like that. Heat up the pin. Everything. Probably left that on the solder iron on there just a little too long. Again, trying to fish it in. That's why a little slack on the wires is a good thing. Okay. Again, just the outer two pins to start. Make sure it's flush. Make sure everything's in line. If it isn't, and looks like there might be a little bit of a gap, I may have to go in there and do a little melting of the solder and make sure that's all pushed up just enough. It's being stubborn. Having recently been to the dentist, I'm guessing that this is kind of like that a little bit, you know. Not that they've had the drill, but just with the pick, if you will. All right. Now there's a nice little spacer that helps you hold on, helps you align the GPS sensor as well that you put in. That mount there. I mean, actually, there's not even a spacer. There's a built-in prop on that mount to get that nice and in line. So you want to tuck in the wires a little bit, and then and make sure that that's the perma board is flush on the mount, and then go ahead and solder in your GPS unit. So doing this, I just always do the outside sort of first to make sure everything's cool. Right? Make sure all the solder is good. There's no cold solders. Trim off a little bit of the excess. All right. I think that's looking pretty darn good. Okay. And here's where, again, I started a little early. So we already have the VBAT in, we have the ground in. I had the 3-volt enable cable that was going to be coming in soon in a minute. Put the coin battery into the put it up, check the wires, make sure all the connections look pretty good, make sure everything's nice and snug. All right. And let's mount it on up, and let's go ahead and start putting our the rest of our wires in here. Okay, so we're going to put in our GPS enable, or positive, from F10 to the positive below A13. Okay, measure it out. Maybe a little bit of slack, not a ton. Okay. And then it's our TX0 to RXN transmission, F6 to A45. And after that, in purple, we're going to do our RX0 to TXL receiving. So if I do believe F7 to A46 in purple. Make sure the wires are bent to back. A little bit of slack. Flux. Really enjoy those flux bends. They're recommended to me by a fantastic engineer and good friend, Arsenio. They work out well. Looking pretty good. Let's plug it on up. Let's see. Alright, now, so drag our code PY from our GPS test code. Check out our mu editor. This is the serial area of the mu editor. And okay, and see it initialize. Everything's looking good. It's finding firmware, and it's getting a timestamp. And it did give me the GPS fix. I did not include the GPS fix on there because I prefer my locale to be secret. All right. So we have that in there. Now we need to install the power button. Okay. And to do so, we are going to install our analog cable. Okay, this is our blue cable that goes from I1 to I2 and to A55. All right, so this is going to be part of our 3-pin coupler. Okay, and then we're also going to install our analog cable, or analog input 1, which is going to go from H2 to H1 to A54, and that's going to be a purple cable. Okay. And once we get those installed, then we're going to install our power switch. Okay, our power control cable is a gray cable that's going to go from J54 to P43. Okay, and then on the rear of the Proto board, we're going to install our power button A43 to the ground below A43. All right, let's add a little flux. Let's solder this bad boy in here. There we go. Come on, get it on in there. There we go. Dwayne Bridges. That was a clean solder iron. That's all it takes. All right, let's take a look here. Let's see what's next. We cleaned up our board. All right, this is where the slack comes in handy. Let's trim this wire up here. Let's get this thing installed now. Feed that on through. Thread the needle. Let's see. Okay. Good. Looking good. Okay. Let's flux that on up. Solder it on in. Clean your board. Now getting the button out, and this particular button, they send it with the red caps. This one's a little bit trickier than the normal one with the black cap on there, so I gotta actually clean this one up a bit. So I gotta trim the pin down a little bit because there's a sort of a fatter end to it. Now this is not the ideal button. Ideal button would be on the parts list. Okay, but this is the one that they sent. So, power switch button. Let's see. So cleaning it up takes a second. All right, taking a look at the wiring, making sure everything's all right. Yeah. Checking out the cold solders, see if there's any points that I've missed. And there's a little something going on with the power switch. See if I can fix that up. Make sure it's soldered in well. Test the continuity. Yeah, there was a severed connection over there somehow. I didn't cut over there, but you know, sometimes these things happen. Alright, let's test this power button on. Alright, now we're going to get our BME temperature and pressure chip, and we're going to go ahead and hook it up to the Qwiic Connect. Oh, excuse me, not to the Qwiic Connect, to the clock. So it's an awkward little space, so I bend it a little bit. Remember the exposed wire side of the plug-in goes face down towards the breakout, towards the chip. Okay, and so once I sort of snake it in, it'll be a little bit easier. Come on, get in there. There we go. Make it nice and snug. You don't want to push it until it's ready to go in, because pins inside there can be kind of fragile. All right, let's get our BME and let's attach it to the end here. There we go. BME 280. Pop it on in. There we go. Plug it up. Turn the power on. Everything should be good. If everything's got a nice little LED glow, except for the clock, of course, we should be good. And we'll go ahead and do our nice system test. Make sure that all the wiring is correct and that we're seeing all the modules that we should be seeing. Alright, so now we're going to hook up our display. We're going to check everything, see how it's working here. Okay. Lock those in, make sure our display screen is working. Okay, and if we had installed our testcode.py from the thing, we might see some stuff over here. Let's see. What's going on? Let's take a look and we'll check out our, there we go. So it's refreshing the screen, so that's looking pretty good. But we want to check and make sure that our BME is being checked out. Okay, so we can go to the I2C bus scan and let's see what's going on with our I2C. It's dropping the circuit pi. Let's take a look. Alright, so I2C address is found. Now if you look up in the code in the Mu editor, you can see what this I2C address is actually are seen. But we're looking pretty good there, so that's good to know. So let's drag and drop, okay, our code and libraries to get everything looking good. All right, and you get to see that it's picking up very. Okay, now we test our systems. It looks good. Now we get to package it. All right, so we got our battery hooked up. We got our display and all that. We're going to get our face here and our GPS. These are all the fun little inserts that you put into the face. So first you want to put in your little charge windows there and your battery window. Okay, and it sort of slides right in. Okay, and we get our base here. Now, like I said, you're gonna have to have some fun. So first you put in your BME, if you put a BME in there, and you hold it down with the spacer. Okay, so I'm gonna get this all organized here. There we go, battery, BME. It's in that nice little space. It's a bendy spacer there, so that you can basically clamp that sensor down so it doesn't move. Okay. You actually have room for another one as well, another bay to put another sensor inside of there. Okay, and then you tuck this one on in. So you need to check out the wires, make sure that the wires are all tucked in really well and all that. And it should lay flush against the base. Okay, So it might take a little finagling. Not too onerous. Okay, once you have it, you'll know. Check the screens, check the sides, you know, make sure there's, again, you might have to push some wires in if it's not laying flat. See, there's a nice little purple wire over there that I see. I'm going to have to tuck it in just a little bit. This is, again, why you leave a bit of slack in all of these. Okay. And once it all comes together, it's such a, it feels really nice in the hands. It's really a great instrument, a great tool. Little adjustments in there. Let's go ahead and use our pliers here. Let's get on inside there and push it, make sure that wire is tucked under and snug. Okay, okay. All right. All right. Looking good. Put our display in. Okay, make sure that it's pretty well. Make sure that, yeah, the little peel is off of the display. Okay. It's booting up just fine. All of that. Okay. Let's go ahead and put our cover on. Oh, let's put our knob on first, and then we'll put our cover on. So make sure that goes in there pretty well. Okay. Faceplate on. There you go. So you see the little areas in the back there. So make sure that the back end goes in first, and then slide it on and snap it all together. It snaps pretty well. Okay. For the GPS, I like to put that in, you know, a little bit later too, and make sure that that snaps in pretty well. Okay. And that's our little SD door. So the SD card stays in there. I make it a nice bright color. That way I know if it's open or closed. Turn this guy on, and there you go, Bob's your uncle. You have a STELLA-1.2 Base Module. Now you get to make all the other fun modules, the sensing modules and all that. Right now we have the Error Analyzer module and the Remote Sensing module that we are working on currently. Error Analyzer module have a nice, will have particulates, CO2, and methane, as well as, of course, ambient air temperature. The spectral module should have the 18-band spectrometer on there, as well as a LiDAR and a surface temperature. Okay, sort of an analog to Landsat. Thank you for your interest in the STELLA 1.2, and have a great day.